In this video, I will be modeling the 45-45-90 triangle theorem, which says the length of the hypotenuse in a 45-45-90 triangle is root 2 times the length of the leg. So here I have a couple of models of 45-45-90 right triangles. Even though I only have one angle, I know the other angle would have to be 45 degrees. Because of the triangle sum theorem, 90 plus 45 plus 45 would give me the sum of 180 degrees. Then, just by knowing that single angle, I should also know that if base angles of a triangle are the same, that means the sides opposite those angles are also identical. So these two legs would be the same, and these two legs would be the same. And that's the isosceles triangle base angle converse theorem that I just modeled. So now that I have two right triangles, I'm going to set up two different models using variables in order to represent what the information in the theorem. So let's pretend for a moment that this side of this triangle is the variable A, and that's a leg in a right triangle. And over here, this side is also the variable A. Since this leg is A, the other leg has to be A. According to the theorem, the hypotenuse would be root 2 times whatever the leg is. So this is going to be A times root 2. And voila, we have a model. I didn't have to use A. I could have used any other variable. So over here, I'm going to use X. And if this is X, this would also have to be X, and then the hypotenuse would have to be X root 2. So numerically, if this length here was, say, 5 inches, then the other leg would have to be 5 inches, and the hypotenuse would have to be 5 root 2. On the other problem, if this is 10, if x is 10 yards, then the other x has to be 10 yards, and the length of the hypotenuse would be 10 root 2. So the two examples that I just gave are very basic examples. It is possible, though, that you will not be given the leg to start with, or that you'll be given a number that's not quite as easy to do with mental math. So let's pretend here for a moment that I have one of my legs equal to, let's say that I have it equal to the square root of 7 here. So this is the length of this leg. Well, that makes the other leg easy to find. This leg will also be equal to the square root of 7. But the hypotenuse, if I have A root 2 for my hypotenuse, I have to substitute in what I know is A, root 7, and I need to multiply that by root 2. Root 7 times root 2, well, that's the same as doing 7 times 2 underneath the square root, and we get the square root of 14. So the hypotenuse was root 14, this leg was root 7, and this leg was root 7. Notice that you can't see the square root of 2 in the final answer, but that the value of the leg was multiplied by root 2 in order to get that answer. Let's take a look at this other problem here, and this time I'm going to use a whole number, but I'm going to use it for the side that was supposed to have a root 2 in it. So I'm going to call this side 15. Okay, we're going to pretend that's 15 units, whatever kind of units those might be. So that means that I don't know what x is. This isn't divisible by 2, and so it makes it hard to find this factor of root 2 in there. So what I'm going to do is I'm going to set up an equation using these two pieces. These are both equivalent to each other. And say that x root 2 is equal to 15. And now that I have that equation, I'm going to actually solve for x. To do that, I'm going to divide both sides by this radical, root 2. And that will cause the variable x to be alone on one side. And on the other side, we're going to have 15 divided by the square root of 2. But in mathematics, we can't have a fraction with a improper radical in the denominator. So root 2 is not an improper, irrational radical in the denominator. So root 2 is like a decimal that keeps going forever with no kind of pattern. We need to get rid of that. We're going to multiply by root 2 in the denominator, because if we multiply the denominator by root 2, it will give us 2. Square root of 2 times itself just gives us a regular 2. But we can't just change the denominator. We have to also change the numerator. And this is a fraction equal to 1. When you multiply anything by 1, it doesn't change its value. And so 15 times root 2 gives me the new numerator of 15 root 2. And the denominator is just a regular old 2. That is one ugly looking fraction. But that is the value of this side. I'm sorry, not this side, of x, is the value of x. So over here, this is going to be 15 root 2 over 2. And the other leg is going to be 15 root 2 over 2. So a little bit tricky, but not impossible to solve. We just had to figure out how to get the variable x by itself. I'm going to give one more example, and this time I will just do something simple. Let's pretend this is a right triangle, and this is 45 degrees, which means this is 45 degrees, which means these legs are the same. So if I give this leg the length of 8, whatever units, then this other leg has to be 8, whatever units, and the hypotenuse would be 8 root 2. And voila, I have another example. I hope this information was helpful. In all cases, we've used the theorem, which states, again, the length of the hypotenuse in a 45, 45, 90 triangle is root 2 times the length of whatever the leg is.